Alright, today we are working on section 2.2, which is page 101 in your book. And we're going to do two things today with our learning goals. The first is we're going to solve three equations, systems of three equations, and we are going to do what's called substitution first. That's our first learning target. Our second learning target is to do the exact same, solving systems of three linear equations, three variables also, and by what's called Gaussian elimination. You don't need to worry about the word Gaussian, just know elimination. Okay? And all of this gets a little complex, so take it slow. This is the first day we're doing this, and then we'll teach you later on how to use these with the calculator as well. But we need to know how to solve them by hand. Alright, so the first thing we do is understand how to do substitution. Okay, so if you flip it over, we have a little word problem here. And just like before, you always need to read through the word problem and define what it is we're talking about. You always must define your variables. So as I read through this, I want to find things that I can compare. Alright, so let's see. As a fundraising event, your club sold tickets to a special viewing of a new summer movie. The fundraiser was successful. You sold all 800 seats in the school's auditorium. You sold tickets in three different prices. Alright, we've read all of that, and now we finally have our situations. We have $2.50 for children under 12. That's a scenario. So when I see this, I think of the money here, I think of tickets, and I think of we're selling them to children under 12. So that's going to be one of my variables. Your variable is usually the item or the thing. So I'm going to call C my children under 12 years old. $3.50 for youth between 12 and 18. So now I have, I guess I'll do a Y representing the youth, because that's the next group of people that I sold to. And the last one is $5 for adults. So I'll do A's for adults. So these are my variables. Always define your variables first. Then once you've defined your variables, you can go through and write an equation. So let's see. You always write equations based off of kind of commonalities, like terms. So when I look at this, I think of that I sold 800 seats. Well, this 800 seats is a total amount of selling. I can't sell 800 seats and worry about cost. I only worry about putting people in the seats. So here's my people. That's my first equation. My first equation is going to say I'm going to sell 800 seats. So to sell 800 seats, I have to sell children tickets. I can sell the youth a ticket. I can sell adults a ticket. And if I add up how many I sold from each group, I have to sell 800 total seats because I sold all 800. So there's my first equation. After that, I can talk about dollar amounts. Well, it costs $2.50 for every child, it costs $3.50 for every youth, and it costs $5 for every adult right there. So I want to go find, if these are money and money and money problems, I want to go find what's the total money. Well, if I keep reading, the total money was that amount right there. So now I can create my second equation talking about how much of each thing. So now I'm going to say $2.50 for each child. It was $3.50 for each youth. And it was $5 for each adult. And if I add all the costs, I'm going to make a total of $2,937.50. And it says and, so now I have a third equation, and there were 4 times as many youth tickets as children's tickets sold. And this one's a little bit tricky, because if you sold 4 times as many youth, what really means is you sold 4 times as many youth. So let's say you sold 5 youth tickets. Well, if you times youth by 4 times as many, that's going to give you your children. So the last equation is going to be, let's see, that 4 times the children will equal all of my youth tickets. And now I have a system of 1, 2, 3 equations with 1, 2, 3 variables. So what we're going to do is we're going to work to solve this. Now the first step to solve this using what's called substitution, and when you substitute, you are thinking of I always think of sporting events, because if I substitute for somebody, they come out and I go in. So we are going to substitute by rewriting some equations. So the first thing we want to do is look at your equations, and you want to isolate one of the equations, I don't care which one, for a variable. And if you kind of notice, this one's already isolated. This y equaling 4c is already isolated. And they used the variable t. We used y instead, so maybe we just rewrite that for a y. But this is a variable that's already isolated. So what we're going to do is we're going to take that equation and to substitute everywhere we see a y. For example, this y is going to equal 4c. So we're going to take that value and copy and paste it right here and multiply 350 times y, but y is 4c. So we substitute here, and we're going to substitute here. So we're going to rewrite our two equations and simplify them out. So my first equation is going to rewrite, and it's going to say c plus, well, here's a y to my first equation. Well, y equals 4c, so I'm going to replace, and I always put in parentheses whenever I change it. So that's really the y value right there. All right, plus a, and that must equal 800. And then I can simplify this down. If I have c plus 4c, I have a total of 5 c's plus 1a, and that equals 800. There's my first equation. My second equation will be this one, and I'm going to plug in y, 4c equaling y right here. So I'm going to rewrite this equation for the money. This is going to be $2.50 times c plus $3.50 times y. Well, y we know is 4c, so I'm going to rewrite that for y. Plus $5 per every a, and it still must equal 2937.50. So again, all I did was take out the y and plug in 4c. Here's my y value for 4c. I made it blue to show you that I'm replacing it with 4c's. Okay, I'm going to combine these up. Let's see. 250c's plus 350 times 4c. All right, so this becomes 250c still plus. These we have to multiply. 4 times 350. Well, that becomes 14. Rewrite everything else. I'm going to combine my c's. I get 1650 c's plus 5 a's, and it still must equal 2937.50. That should be plus in black. Alright, now I have two equations with two variables. So I'm going to keep doing the same thing. I'm going to look at my equations. I'm going to find out which one can I substitute or solve for one variable. And I'm looking at this y, this a right here, this one. This has a 5a, this has 1650 c's, this has 5 c's. If I get a over here by itself, I could simplify it and plug it into the other one. So now I'm going to keep going with that process. So now we have two systems with two variables. You might want to read what this little girl here has to say, because it might help us out. But we're going to rewrite this as a, and then what we are going to do is move the 5 c's to the other side by subtracting. So this becomes minus 5 c's. And we are now going to copy and paste this right here for a and rewrite our equation. So this now turns into, I'm going to write it down here just because I have some space, 1650 c plus 5 a's, but a represents this, 800 minus 5 c's. And that now has to equal 2937.50. So I copied this equation down and plugged in a with whatever a was. Now I'm going to multiply through. This becomes 1650 c's plus 5 times 800 is 4,000 minus 5 times 5 is 25 c's, and that has to equal the same number, 2937.50. I'm going to combine my like terms. So let's see, I have 1650 c's and minus 25 c's. That's going to give me a negative, let's see, that's going to be 8.5 C's plus 4,000 equals 2937.50. I'm going to simplify this. I'm going to subtract. Here we go. I'm going to subtract 2937.50 minus 4,000, and I get negative 1,062.5. And then to get C by itself, I'll divide by negative 8.5. And now I get the number of C's, which is children's tickets. I have 125 children's tickets. All of that work to get the number of tickets. But now what we'll do is we'll start moving up our chain, back up to the top, and we're going to plug in C and find how many A, or adult tickets, we get. So now once we found one, we can just start kind of plugging in. So now we're going to use this equation because it's already solved for C, and I know C is 125. So now I can say that the adult tickets equals 800 minus 5 times 125. And I'm just going to go to the calculator at this point. 800 minus 5 times 125. And I get that adult tickets are 175 sold. So now I'm going to write down adults equals 175. So I got my children's tickets, I got my adults tickets. If I look here, children, adults, all I need is my youth, and as I look through all of these, the only equation that has a youth is this one in it. So I'm going to do 4 times the children's tickets, which is down here, is going to equal my youth. So that means youth must equal 4 times C. So let's see, 4 times 125 equals 500 for my youth. So there's my 3 answers, and again, I've already solved all of them using what's called substitution. So what I want you to try to do is work with your table. I know this is a little bit tedious and long. Alright, what I want you to try to do is look through. We've already done this part where it says solve on the next page. We've already done all of that. I want you to look on the back on number 4, and you with your table need to try to solve this equation. So before you do that, read through what Allison and Emily are doing here. If you notice, they have a thumbs up for both of them, which means they are doing them correct to start. They have kind of started these problems out for you. Okay? So you're using the same 2 equations. They want to first get one equation with one variable, and then they're going to kind of work through all of that. So see if you can't read through all of that. What you're going to do is Part A, describe the similarities and differences. Part B, you are going to now find the solution for both. And then you could even answer Part C is, could this system have been solved using a different type of substitution? Did they do it the right way, or is there a different way they could have done it? And explain your reasoning. So the first thing you're going to do is that with your table. Okay, so I'm going to pause the video there. You need to work those out, and please check your answers on the answer key with the sub. Alright, if you've done that now, hopefully you've checked those with the sub. You should hopefully are getting the right answers, or some right answers, similar answers. I want you then to do the exact same thing we did as a group there. I want you to do that number 5, Part A and Part B. You're going to formulate a system of equations. Remember, identify your variables first. Okay, right here, define your variables. Write your equations. Then see if you can't use those to calculate each item. Okay, check the answers with the sub again, and I'll pause this now before we go on to elimination. Okay, the last part of today's lesson is going to be solving using what's called elimination, and sometimes they call this Gaussian elimination just because that's the person who invented this. And it's the same exact idea, only it's a little bit faster with Gaussian elimination because you are going to try to stack up your equations, the x column, the y column, the z column, and the answer column, or whatever your variables are. In our first equation, we had children, youth, and adults, so it could be the c column, the y column, the a column, and the answer column. No matter what, as long as you set it up like that, you can still use elimination. And you've probably done this before from Algebra 1. So this right here, this part on page 107, kind of just explains what's going to happen. Now you can do anything with these equations as long as you are consistent within each equation. For example, I could double the first equation as long as I double 2 to 4, double y to 4, double z to 6, and double the answer to 6. I could triple all of them as long as I'm consistent. I could do the same with the middle one. I could double all the middle answers if I wanted to. Or the last one. Doesn't really matter. But the goal with elimination is to try to take two equations. This is equation 1, equation 2, equation 3. Try to take two of those three equations and eliminate a variable. Doesn't matter which variable you eliminate. From right here, if they're taking what looks like to be the second equation, number 2 here, and it looks like they want to eliminate the x's. And if they do that, if they had a 2x here, here's our 2x with the first equation. If they could make that a minus 2x, these x's would cancel. So what they did is they said, all right, take everything in the second row and make it a minus 2 times that whole row. So it's still the same equation, just a dilation it's called, because we've doubled all the rows, all the numbers. So negative 2 times x makes negative 2x. Negative 2 times 3y's makes negative 6y's. Negative 2 times 2z's make negative 4z's. And negative 2 times 5 makes negative 10. And then what they did is they combined the columns. So they took the first equation, right here, this is the first equation. They doubled the second equation. And then they just combined the columns, kind of like adding x's, adding y's, adding z's, adding your answer. And they got this new equation. I'll put this equation so you can see a little better in green, which is negative 4y minus z equals negative 7. So that's our first new equation. And notice we have eliminated the x variable. And we now just have a y and a z. So the second step is to go back up here, and since we used the first and the second, we ignored the third, we now must use the third equation. Okay? So it doesn't matter which equation we use with 3, but we want to eliminate the same variable x. So I now want to get the last equation I haven't yet messed with and get rid of that x. So I want to do it the same way we did it before. I want to take one of these two equations and multiply, if I need to cancel x. And what I'll do is I'll probably take this one, let's see, this middle one, because it has an x, that has a 3x, so if I could get this to be minus 3x's, they would cancel each other out. So I'm going to take this middle row and multiply it by 3, but make it negative 3 so that it can cancel. And that's what they did right here. They took that equation in the middle, multiplied it by negative 3. So they distributed, 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 distributed again, and they wrote all these answers right down there. So this, so you know, is the second equation. And this one, as you can tell, is the third equation. And the reason they took the third equation is because they already used 1 and 2 up here. So now they got to use 3, and they're going to eliminate the x. And once they get the 3's and the negative 3's to line up, they can cancel. They can combine the y's to make, I'll do it in blue, negative 8y. They can combine up the z's to make minus 5z's. And they can combine up the answers to make negative 11. And now they have two equations with two variables. So from there, we're going to take this green equation and this blue equation, and we are going to combine them the same exact way. Okay, you can either cancel the y's or the z's by multiplying one of them by a number. I would probably cancel out maybe, I don't know, my y's perhaps. I could make 4 and 8 by doubling this one. And then I'm going to cancel that variable out entirely. So what they have done here is they have on the back started you right here. There's the last two equations. They've just written the third one up there so you can have. And they've kind of started walking you through each step. So I want you with your table to work with number 1. See if you can read what they're doing and see it and understand how they are solving all of this. Check your answers with the key when you are finished. Alright, once you have finished and you've checked your answers with the book there on page 108, you are free to pick up the homework assignment and start working on that. You don't need to worry about any of the other problems there in the section. And this will be due next class period. Let's see, I lied. This will be due on Sunday night. I will have that in Google Classroom. Please check in for my notes, homework keys, all those things on Google Classroom. and get to work on those, and use your notes as best you can. If you are having difficulty with this stuff, obviously work with table groups, work with other table groups, and finally come see me for tutorials before school or during advisory, and I'll be happy to help you out. Thank you guys. Good luck.